Alright, let's look at homework 17, problem number 1, part B. Alright, so we want to find the scalar potential such that the gradient of phi is equal to negative of the conservative field. Alright, so we'll have, so gradient of phi would be partial of phi with respect to x, comma, partial of phi with respect to y, comma, partial of phi with respect to z. Right? And this is equal to, right, negative of that, so that will be 3y minus 3x squared y z, comma, right, second part would be 3x minus x cubed z, comma, right, this is going to be simply negative x cubed y minus 2z. Right, so by matching, partial of phi with respect to x equals this, right? We can find phi by taking the antiderivative of this guy. So antiderivative of 3y minus 3x squared yz with respect to x, right? So this will get you, so 3y is just going to be a constant, so you have 3xy, right? So this guy minus yz is just a constant, so antiderivative of 3x squared would be x cubed, so it's a x cubed yz, right? Then you might have some function of y and z. Alright, then we're going to match the partial of phi with respect to y with this guy right here. Alright, so if you take the partial derivative of phi with respect to y, it's going to be equal to, alright, take the partial with respect to y, so you're going to get 3x. Partial of this with respect to y would be negative x cubed z. Alright, then you can see that, let's see, then you have h to the partial, so we have that. And let's see, then you have a derivative of this guy, so partial derivative f with respect to y. Alright, and this is going to be equal to, right, so it's a 3x minus x cubed z, right? So this tells you that actually you have exactly the same thing sitting on here and here, right? So partial of y with respect to f with respect to y would be 0, which tells you that f is going to be simply the function of just z, right? So this turns out to be right here. So this guy turns out to be f of z. So there's no y in it, right? So then we take another partial with respect to phi with respect to z, right? Then partial with respect to this guy is 0, partial of this with respect to that we negative x cubed y plus, and the derivative of f with respect to z, right? And this is going to be equal to negative x cubed y minus 2z, right? then you can see that we can cancel negative x cubed y, negative x cubed y, right? So this is going to be, right, take then f of z would be the antiderivative of negative 2z with respect to z, which is going to be negative z squared plus some constant c, right? So therefore, we have a complete formula, right? So you have a so phi is going to be 3xy minus x cubed yz, and then this turns out to be negative z squared plus some constant c, right? So that is the function phi, scalar potential that we're looking for. Alright, that's it. I hope that this was clear.